Now let's talk about the rules of naming alkenes. So the general rules are quite similar to the ones we used before in naming alkenes. So the first thing you need to look at to find the longest chain of carbon atoms that has the double bond. Okay, so the longest chain that contains the double bond, this will be your parent or your root name. And then use the suffix "-ene" for alkene, and give and then you need to number the long chain from a position which gives the double bond the lowest possible number. At the end, you look at the different substituents and give them their number. And don't forget to, when you write the name, you write the different substituents in alphabetical order in the same way we did with the alkene. So let's have an example to see exactly how to do this. So this is an alkene, as you see here, because we have a double bond. So where would be the longest chain? So let's count and see which one would be the longest chain. So first of all, the alkene here. So I'm going to include this in the my chain, and the longest chain would come 1, 2, 3, 4, 5, 6, 7. So this is the longest chain. This is not an ethyl substituent here. This one here is not an ethyl substituent, and this is part of the chain. No. Now you have the longest chain as I have numbered it because it's the longest chain. It has 7 carbon atoms and all are in the same chain which has the double bond. So now at the end you're gonna have the 7, the double bond will be um, the double bond in position number 2, so it's going to be 2 heptene. Because we have double bond here at position number 2. Now let's look at the different substituents. So we have two substituents, one in position number 3 and one in position number 5. So we have two methyl substituents in position number 3 and 5. We don't have any other substituent, so it's going to be 3, 5 dimethyl 2 heptene. So this is how you do it. Just number, look at the longest chain that contains a double bond, number it from the side, which will give your double bond the lowest number, not your substituent this time. So now we are looking at the lowest number for the position of the double bond. So it's going to be 2 heptene. Then I look at the different substituents and I will add the will add the name of this substituents. For now, I had at position number 3 and 5, we had two methyl groups, so we said dimethyl. If you had something like ethyl, so let's say if you have as well an ethyl substituent in position number 4, like this, okay, then it will come as 4-ethyl 3,5-dimethyl 2-heptene because we have an ethyl group in position number 4 here. Okay, so look at the longest chain that has the double bond. Number it from the side that will give the double bond the lowest number, and then give the substituents. Look at the substituents, give them their numbers, and arrange them in alphabetical order. Ethyl will come before methyl because when we arrange it in alphabetical order. The word di means two, so it's not in, we don't include that in alphabetical order for the substituents. This is another example. So here for this compound, as you see in front of you now, you have the longest chain here is this one. 1, 2, 3, 4, 5, 6. It has 6 carbon atoms, so the longest chain has 6 atoms. We number it from the side which will give the double bond the lowest number because the double bond here will be number 2. But if I numbered it from the other side, it will be 1, 2, 3, 4, 5, 6. The double bond will be 4. So now it's we will number it from the left, not from the right. So as you see, I number it from the left, not from the right, and it will be 6 carbon atoms, so it's hexene, and because the double bond at position number 2, so it's 2-hexene. This is the root name. And then there is only one substituent in position number 2, which is a methyl group, so it's going to be 2-methyl 2-hexene.